Here's problem 3040. Figure shows a cross-section of 3 parallel wires, each carrying a current of 24 amps. The currents in wires B and C are out of the paper, while that in wire A is into the paper. If the distance R is 5 millimeters, what is the magnitude of the force on the 4-meter length of wire A? Alright, so we have two wires, B and C, where the currents are coming out towards you. And we have a third wire, A, where the current's going into the page. If the currents are going the same direction, the force on them is attractive, but if they're going opposite directions, the force is repulsive. So between B and A, there's going to be a force, it's called F1, that will be repulsive on both of these wires in opposite directions. And between C and A, there will be another force that's repulsive, equal and opposite between these two wires as well. So we're going to have two forces going to the left in the same direction. So if we could figure out the magnitude of these two forces, we will add them together and that'll be our net force in the direction to the left on wire A. So force 1 is going to be equal to mu naught current A times current B times the length of wire A over 2 pi times the distance between them. It's called D1. So that's going to be 4 pi times 10 to the minus 7. They all have currents of 24 amps, so this is going to be 24 times 24. We have a 4-meter length of wire for wire A over 2 pi, and the distance between them is 2r, and that's going to be 10 millimeters altogether. So we'll have 10 times 10 to the minus 3 is our distance between these two wires. 4 pi divided by 2 pi is 2, and well, let's just, what do we got? We got 2 times 24 times 24 times 4. Then we have 10 to the minus 7 or 10 to the minus 2, which is going to be 10 to the minus 5. And this is equal to 4.61 times 10 to the minus 2 newtons. Directed to the left as shown. For the other force, F2, we have mu naught. It's going to be the current in A times the current in C times the length of wire over 2 pi. We're going to have a different distance of D2. Mu naught is 4 pi times 10 to the minus 7. And then we have 24 amps. 24 amps. Length of wire of A is 4 meters. All this over 2 pi. Now the distance between them is actually 3r, because we have a 2r plus another r, 3r, which is going to be 15 millimeters. So this would be 15 times 10 to the minus 3. So the 4 pi over the 2 pi will give us a 2, and let's just plug this into our calculator. 3.07 times 10 to the minus 2 newtons for this force, and that's also to the left. So these two forces are in the same direction. They are going to add. The magnitude of our net force is going to be the sum of these two forces off to the left. So this is going to be 4.61 plus 3.07 times 10 to the minus 2, and that is going to be 7.68 times 10 to the minus 2 newtons. Both of them adding to the left. Or we can call this, if we wish, about 77 millinewtons is our net force to the left.